The title of this session by Rudy Neufeld is Introduction to Coding Through Robotics and Logo with a Math Focus, a hands-on workshop with follow-up opportunities. This session models a learning environment which encourages one to learn by coding or teaching a robot. We capture interest through an interactive video to introduce code and corresponding action. Then we encourage further exploration through hands-on activities by giving participants free access to an ebook of activities and the logo computing code to control a robot on their own computer screen during or after the workshop. A session testimonial after an NCTM conference states, "This session is an intuitive, simple, yet powerful introduction through lessons to vital coding skills and personal access to a programmable robot on a computer screen." Great activities in an ebook present hands-on opportunities to enrich STEM with a math focus. The material in this workshop is taken from the Introduction to Coding ebook, which can be accessed by participants at www.umathx.com under Coding. We will refer to specific pages in this ebook. You can access pages in the ebook now or later for specific activities in your own time. Here is the table of contents. As an introduction to this workshop, we list a number of helpful comments from the foreword and the preface of the ebook. Coding creates a learning path and gives the learner direct participation in and responsibility for his or her own learning. Manipulatives help to move the learner along the pathway from concrete to abstract. This is critical in the learning of and understanding of mathematics. Robots engage the minds of students, teachers, and parents in rich, exploratory, open-ended inquiries, thereby creating communities of innovation as they work together and share explorations and findings. Teachers and parents make learning possible for all students by establishing an environment of risk-taking. In the flow of our learning, in chapters 1, 2, and 3, we begin with self-movement for the person robot, followed by activities with a mechanical robot, a bluebot. Finally, we present activities to code a robot on the computer screen. In step 1, a person walks the code. In step 2, the coding is done using bluebot keys on the bluebot. Later in step 2, the bluebot is coded using a computer keyboard. And in step 3, the robot moves to the computer screen and becomes a turtle. It is now coded with keys on the computer keyboard or tablet. Step 1. The first steps to coding. On top of page 17, a person walks the code. Then in step 2, we work with a robot, the bluebot, on the floor. Code a floor robot, the bluebot. The prediction activity chart on page 29 is to be used with an investigation activity. The user would predict, record, and test at each line. For example, in line 3, one should predict, clear, move 1 unit back. The bluebot brings science, technology, engineering, and mathematics into the classroom and builds foundational skills for lifelong learning. One can move the bluebot forward, backward, turn left and turn right, and teach sequencing, directionality, problem solving, counting, and estimation. Now we make the jump to step 3. Chapter 3. Coding logo on the computer.